Hey everybody, this is question 14.17 out of Brown LeMay Burston. Wanted to give you a little bit of just kind of maybe question that you can just look up the answers or, check to see if you're thinking about it the same way that I am. Okay, and so here, with these sorts of questions where I have to write a lot, I may actually not write out the whole thing. I may just give a couple of symbols, but listen to what I'm saying when I give the answer here. Okay, and so it says, what is meant by the term reaction rate? Well, a reaction rate is, first it's symbolized by R, and a reaction rate is the change in concentration during a reaction of some sort of element or compound. Okay, so it's a change in concentration. The square brackets indicates concentration, okay, of something that's in there, okay, and that is compared to the change in time. And I use T with a dingus. I call it a dingus. Okay, that little part is called a terminal. I call it dingus. It's more fun to say, funner to say. Okay, and so the neat thing is that as we change the concentration, the time can change, how long the reaction takes will change. And so this is all dependent, this is all the things that are dependent on the rate, okay? And so a rate is a relationship, if I was going to be very specific and not vague about what a rate is. The reaction rate is the relationship between the change in concentration over time of the reactants or the products in that reaction. Okay, so for part B, it says name 3 factors that can affect the rate of a chemical reaction. Well, one of the things that can affect is right here is concentration. Okay, concentration is a huge thing. Okay, another thing that can affect the rate of reaction is temperature. Okay, temperature is another big factor. Actually, one of the things I can say is the rate constant is the same for a reaction as long as the temperature stays the same. As soon as you change the temperature, the reaction rate, or the reaction constant, the rate constant, but get your act together here, Walsh. Okay, the rate constant will change. So temperature has a big effect on the rate constant, or on the reaction rate. Okay, a couple other things. Maybe another one would be if there's a catalyst present or an inhibitor. Okay, catalysts change the pathway of a reaction, and that's how it will speed up a reaction. It'll change its mechanism. Okay, another thing that you could talk about maybe is the surface area. If you have more surface area on which to do the reaction, since there's more reaction going on there, then you can since there's more places for the reaction to go and react upon, then the reaction rate will be affected. Typically, it'll be affected up. Okay, and then question C is definitely all about related rates. And I don't know why I have my calculator up, but here we go. Okay, is the rate of disappearance of reactants always the same as the rate of appearance of products? And the answer to that is a resounding no. They're always related, but they're not the same, and it's always dependent on stoichiometry. And so if you have 2A reacting to form B, okay, the rate of disappearance of A is going to be twice as fast as B. Okay, and the opposite is true. The rate of appearance of B, because it's a product, rate of appearance of B is going to be half as much as the disappearance of A. And so we can write that either way. And so that's the idea of related rates. So this kind of gives you some of the groundwork for understanding, or a question that questions your knowledge of kind of the groundwork reaction rates. So have a great day.